Hello friends, today we are going to discuss all about the projectile motion. So let's begin the video. A projectile is nothing but an object thrown up into the sky which moves in a curved path under the influence of gravity. So the best example for the projectile motion is the game Angry Birds. So here we will take this example to proceed further. Generally, all the projectiles are launched aiming at a target. And the main factors we control to hit a target are the magnitude and the direction of the initial velocity. Let's say the projectile travels a distance r along the x-axis and h be the maximum height attained by the projectile in its path. In order to simplify this, let's break down the projectile motion as motion along x and motion along y. Along the x-axis, we don't have any force acting on the projectile. So the acceleration along x-axis is 0, and along y-axis, we have acceleration due to gravity towards the earth. Along the x-axis, the component of initial velocity is u cos theta. These components u cos theta and u sin theta are nothing but the projections of u on x and y axis. So along the y axis it is u sin theta. If Tf is the time of flight of the projectile, then the time of flight will be same along x and y axis. If we look at the projection on the y axis, then we can say that the projectile goes to the maximum height and returns back in time Tf. Whereas if we look at the projection on x axis, then projectile will cover a displacement r in time Tf with uniform velocity. And we will say the time taken to reach the maximum height as time of ascent and the time to return back as the time of descent, represented by Ta and Td respectively. So now we can apply equations of motion on this projectile, and if you don't know about equations of motion, please check out my previous video and the link is in the description. So along the y-axis in time interval Ta, it reaches a maximum height, so Vy is equal to 0 and the displacement will be equal to the maximum height h. Thus, we can find the maximum height reached by the projectile as u square sin square theta by 2g. Now let's consider first equation of motion along y-axis, which is v equal to u plus at, and this equation gives time of ascent Ta as u sin theta by g, which is further equal to time of descent. So we can find the time of flight by adding Ta and Td. Now let's take second equation of motion along the x-axis, which is s equal to ut plus half at square. And along the x-axis in time interval Tf, the displacement is equal to r. So by substituting Tf, which is 2 times of Ta, we will get r equal to u square sin 2 theta by g, and we generally call this as range of the projectile. Till now we have seen how to find the range of the projectile, and for a given velocity u, the maximum range that can be attained is u square by g, because the maximum value of sin 2 theta is 1, which implies 2 theta equal to 90 degrees. That is theta equal to 45 degrees. So in order to attain a maximum range, we have to throw the projectile at 45 degrees for a given velocity. We can write this sin 2 theta as sin of 180 minus 2 theta, which shows sin 2 theta is equal to sin of 2 into 90 minus theta. So we can say that for a given velocity thrown at an angle of theta or 90 minus theta will result in same range of the projectile. Please note that all these equations are derived neglecting the air resistance. And at the maximum height, the projectile will have only the horizontal component of the velocity, which is u cos theta. We know that the projectile will travel in a curved path, but we don't know exactly what is that curve. So in order to know that, we need to derive an equation of the curve followed by the projectile. Let's consider after t time, the projectile has reached a position as shown. By using the second equation of motion along the x-axis, we can get t equal to x by u cos theta. And using the same equation along the y-axis, we can get y equal to u sin theta t minus half gt square. Now using the previous equation and substituting for t, we can simplify this as y equal to tan theta x minus g by 2 u square cos square theta into x square. And this equation is in the form of y equal to ax plus bx square, which is a generalized form of parabolic equation. Thus we can say that projectile thrown will follow a parabolic path. Check out the summary of the video and do the practice problems. Don't forget to check out my next video, because in that we are going to discuss how to solve the complex problems in an easy way. So please do subscribe for updates and like the video. Thank you.